Okay, we get into integration where it's equations, double integral equations, but it's hard. You can't really do the switch. And I think Pindon will tell you, apply polar. So for example, from root pi to minus root pi integral minus pi y squared pi y squared, and it's sine x squared y squared dx dy, and he's telling you to use polar. Even if he doesn't, you'll see integrating this with respect to x is hard, and also with respect to y is hard because the derivative is not outside. So we need to make the switch. Remember, when you make the switch, obviously r squared is x squared y squared. X is r cosine theta, y is r sine theta, dA, which is dx dy, is r dr d theta. So we make the switch. So we start with sine. This plus this becomes r squared. Dx dy becomes r dr d theta. We need radius first. If you look at this, the number here, radius would always be the square root of the number that's next to the y or next to the x. So your radius limits goes from 0 to root pi. And theta, always put complete circle, 0 to pi. So sine of r squared and r outside. So since the derivative is outside, hide the derivative, and the integral of this would be minus cosine, and there is a 2 extra over 2. You put root pi and 0 from 0 to 2 pi. You start plugging. If you plug root pi, square it becomes pi. Cosine of pi is negative 1. And negative becomes 1 over 2. Zero to 2 pi. Minus. Plug 0. Cosine of 0 is 1, so minus half. So basically, it's half plus half 1. The integral of 1 is theta, 2 pi, 0. The answer is 2 pi. So the answer for the question here is 2 pi. We do another one where we have to switch to polar. Negative 1 to 1, minus 1 minus y squared, 1 minus y squared. You'll notice even if he doesn't tell you that you need to do it polar, you'll see that it's really hard to be able to do this without switching to polar. I know this is dA, and it's r dr d theta. So x squared plus y squared is r squared, and here I can put r dr d theta. Limits for r. I told you, from here, radius would be the square root of the number. So in radius, we're going 0, 1, complete circle. The derivative of the bottom is on top, so that's ln of the bottom right away. Ln of this, there is a 2 extra over 2. You plug 0, 1, and you put a d theta 0, 2, 5. You put 1, that's ln 2 over 2. You put 0, that's ln 1 over 2. D theta, that's 0. A constant would be the constant theta, and 2 pi and 0. Put the 2 pi, will give you 2 pi over 2 pi. Put the 0, 0. The answer is ln 2 times pi. This is all you need to do or to know if you're integrating polar. Or integrating double integral and you switch to polar. Sorry. Before I do, well, I'll do this one. So now, this question, evaluate and draw. 0 to 2 cosine theta, 0 to pi over 4. The function r cosine theta, r sine theta, r dr d theta. It's given to you in polar, so you don't need to switch or anything. So, and use it to integrate when the function equals y. So you're integrating y basically. Now to draw this, your r is 2 cosine theta. And your theta, 0 to pi over 4, 45 degrees. I'll add one more, 30 degrees, to know how my radius is going to look like. And I plug the three numbers. 0 gave me 2. When I plug this one, it gives me 1.7. And when I plug this one, it gives me 1.4. So if I go here, this is line for angle 45 degrees. So 1, 2, 1, 2. So at 0 line, radius is 2. At the 30 degree, which is this line here, you're 1.7, and then you're 1.4 at the 45 degree. The curve would look something like this. Okay, I don't know if sketching helps with anything, really. So when you integrate, you're integrating y. And now if you switch back to x, so no, here you have polar. I'm going to try and switch back to the normal y dy dx, meaning after sketching, if I integrate y, and this is y, r sine theta. So 0 to 2 cosine theta, 0 to pi over 4, y, which is r sine theta, times r to become squared, and then dr d theta. So the integral of this with respect to r would be r cubed over 3 sine theta. You put 2 cosine theta, you put 0, and then what you get, you integrate from 0 to pi over 4. In r you put 2 cosine theta, so it becomes 2 cosine theta cubed over 3 sine theta minus 0 d theta and 0 pi over 4. 2 cubed is 8, so I can put the constant 8 over 3 outside, and I have cosine cubed theta sine theta. You can do this u sub, or basically, this is the function, this is the derivative, hide the derivative, add 1, divide by the number. And the derivative is negative, so you just put a negative outside. In fact, the negative of the constant, 8 over 3. And you have pi over 4 and 0. Cosine pi over 4 is 1 over root 2 to the power 4. It becomes 1 over 4. Divide by this 1 over 16. So 1 over 8/3, 1 over 16 minus 8 over 3. And 0 here will give you 1 over 4. Well, you can do this in the calculator at this point. And eventually, when you do all of this, the answer, I don't know if I have the final answer. I think it's probably half. But you can put in the calculator and that tells you what the answer is. Good? Okay. So you have a question where you integrate and it doesn't tell you to switch to polar or anything, but you know, usually when you see x squared and y squared, which is r squared, switch to polar. So you're integrating this and you go, this is r squared to the 7 over 2, and dA I know is r, dr, d theta. They tell you in the question that it's a unit circle, so radius is 1 complete circle. So when you raise to multiple exponent, you multiply them, this becomes r to the 7 times r, so it's like integrating r to the power 8. Which is 9 over 9, 0, 1, d theta, 0 to pi, 1 over 9, d theta, 0 to pi, it becomes 1 over 9 theta, 2 pi and 0, so the answer 2 pi over 9. Good. So far, we did double integrals, numbers. We did double integrals, equations, straightforward. Double integrals, equations need to switch. And we did double integrals, polar. So you need to know all of them. So there will be a question straightforward. There will be a question with equation. There will be a question where you need to switch equations. And there is a question with involving polar. So you need to master all of them. Now we get into triple integral. Again, there will be a question, triple integral, straightforward. Triple integral, straightforward, like this one, or equations. I don't know if this is straightforward. We'll see now. 0x, 0, 1. And it's x, dz, dy, dx. The integral of this is xz. We need to plug x minus 1 and 0. You plug x minus 1 into this, gives you x squared negative xy minus 0. So that's the result for the first one. X squared xy. Now I need to integrate this from 0 to x, 0 to 1. With respect to y, this is x squared y, and that's 2 over 2. We plug 0 and x. X will give you x cubed. X will give you x cubed over 2 and 0. This minus this will be x cubed over 3. So now I'm integrating x cubed over 3 dx, which is x4 over 12. You put 0 and 1, so 1 over 12. So this is 2, yeah. So over 8, 1 over 8. So not bad, straightforward. So don't need to switch or do anything special. So what if it's triple integral and you need to switch? You go from 0, 1 minus x minus y, 0, 1 minus x, and 0 and 1. And it's a function in terms of x, y, and z, dz, dy, dx. The z here means that your limits for the first one, z, between this and 0. dy means that the limits for y are 1 minus x and 0. And x means the limits for x are 1 and 0. You're going to do this table in the exam. I find this table very helpful. So you have x, y, and z terms of x, y, z multiples. The reason why I'm doing this, because the question was, it's integral dz, dx, dy, can you switch to dy, dx, dz? There will be a question in the exam asking you to switch. Okay, in order to switch, let's see what we have. We have z in terms of multiple. Z in terms of multiple are 1 minus x minus y and 0. I have y in terms of x. Y in terms of x is 1 minus x and 0. And I have x numbers, and that's 0 and 1. I need to have y in terms of multiple. So y in terms of multiple, I need this one here. And I need x in terms of z. X in terms of z, I need this one here. And I need z numbers. I need z numbers, I need this one here. Let's start y in terms of multiple. If I take this equation and solve for y, bring the y over, bring the z over, it'll be 1 minus x minus z. So I know that y multiple would be 1 minus x minus z, and y can go down to 0. So it would be 0, the lower limit. I also need x in terms of z. Now, x in terms of z only, you'll see that, well, is there a relationship that relates x and y together? Well, you see from here, x in terms of z, I can use the same equation. But since I need x in terms of z, I let y to 0. I don't need y because I need, again, listen, I need x in terms of z, I don't need y, set y to 0. Set y to 0, then x equals 1 minus z. So I know now that x in terms of z is 1 minus z, and x can go down to 0. The numbers for z, you can figure out the numbers from here. If you put 0 and 0, so that would be 1, 0. So the numbers for 0, for z, 1, or 0 and 1. So now we're ready to integrate. The function x, y, and z. We need the order dy, dx, dz. Starting from the y in terms of multiples, 0, 1 minus x minus z. X in terms of z, 0, 1 minus z. Z numbers, I should have put them here, 0 and 1, so 0 and 1. This is how you make the switch for multiple units. Okay, so we did this question. There is another question, but again, I want to stop this part. We'll continue in the next one.